Rahman Rahim, dear student, Assalamu alaikum. Today's lecture is about class 10 subject physics. Topic of today's lecture is I'm going to 11.3 topic we are going to do today. I haven't mentioned over here, but the topic is 11.3, which is on page number 26 of your class 10th textbook. If please, when we do the lecture, please open your book page number 26, 11.3 topic we are going to do today. Reflection, echo or sound. So we are doing chapter number 11. We are doing chapter number 11, which is related to sounds. So reflection or echo of sound, this is our today's topic. When I read the topic first for you. When we clap or shout near a reflecting surface such as a tall building or a mountain, we hear the same sound again a little bit later. What causes this? This sound which we hear is called an echo and is result of reflection of sound from the surface of a student. Have you ever noticed that whenever you are standing near a tall building or a mountain, or you clap or shout, after some time you will hear the same voice again back to you after some time. This sound we hear from when we are standing near the tall building or a mountain. This type of sound is called an echo. And this is because of the reflection of sound from the surface. Because if there is an empty room, you can take another example of echo. If there is an empty room, there is nothing in the room. So if you clap or shout, and after some time, you will hear the same echo or same sound again. This type of sound is called echo, or the other name of this echo is reflection of sound. So I read the definition of reflection of sound again. When a sound is incident on the surface of a medium, it bounces back into the first medium. This phenomena is called echo or reflection of sound. When sound is incident on the surface of a medium, it bounces back into the first medium. This phenomena is called echo reflection of sound. For example, in this case, when you are standing near the building, tall building, so when you shout, so this shouting will go to the tall building. So this is the incident on the first medium, and after some time it come back to you. It means it is coming. This echo is coming. This reflection of sound is coming back to the same medium again. It is coming back to you. So this phenomena is called echo or reflection of sound. Again, you need to memorize this definition, new definition, and you need to write this down because this come in board examination definition. They can ask you uh, define echo, or they will not say echo. Sometimes they will say echo, and sometimes they will say reflection of sound. So you should know both these words, what they are asking. If they say echo, the same definition you will write. If they say reflection of sound, you will write the same definition again. So from here to here, you got to memorize this definition. When sound is incident on the surface of medium, it bounces back into the first medium. This phenomena is called echo reflection of sound. Incident on surface of medium means it is flowing on the tall building and coming back to this first medium. So when you are shouting, it means this is your first medium. It is incident on the other medium and coming back to the same medium. This type of sound is called echo or reflection of sound. So you should memorize this definition by heart when you do this. The sensation of sound persists in our brain for about 0.1 second. To hear a clear echo, echo, the time interval between our sound and the reflected sound must be at least 0.1. What does this mean? To hear clear echo, if you are in an empty room or if you are near a tall building, if you want to, whatever you shout in front of the tall building, if you want to hear the clear echo, the distance, the time interval between our sound and the reflected sound must be at least 0.1 second. If you want to hear it clear echo, then the time difference will be time must be 0.1 second. If we consider speed of sound, let's suppose the speed of sound is to be 340 meter per second. This is the speed of sound, which is 340 meters per second at a normal temperature in air. If the temperature of the air is normal, so our speed of sound will be 340 meter per second. To hear, if we will hear the echo after 0.1 second. The total distance covered by the sound from the point of generation of the reflecting surface and back should be at least 340 multiplied by 0.1. It will be 34 meters. So it is a time when we shout, and this will incident on the tall building, and coming back to us. This is the total time. This is the total time for the echo. The distance between this will be 34 meters. But if we take it on one side, the distance will be 11 meters, or one when we're going. So it means the distance will be 17 meters. So half of 34 meter is 17 meters. Thus, the hearing restriction equals the minimum distance of the obstacle from the source of sound must be half of this distance, which is 17 meters. Echoes may be heard more than once due to successive or multiple reflections. So we discussed about the echo or reflection of sound in this topic. So this is the definition of echo or reflection of sound, and this is the distance, or this is the uh, the minimum time which is required to hear the clear echo is 0.1 second, and distance from one shouting to the tall building and coming back to us again, the distance is 34 meters. But if we talk about half of this meter, that will be 17 meters. So echo may be heard more than once or successive or multiple. Sometimes we hear more echoes, not one echo, we say more times the voice. We heard the voice more times. This is because echoes may be heard more than once due to the successive or multiple reflections. Because the sound reflects not on the tall building, it reflects on other things. So that's why we hear a multiple echoes. So activity 11.3 we do now. Take two identical plastic pipes of suitable length as shown in figure 11.10. I will show you in a bit. Uh, we can make the pipes using chart paper. So take two identical plastic pipes of suitable length. Arrange the pipes on the table near a wall. Place a clock. Arrange the pipes on the table near a wall. Place the clock near the open end of the one of the pipe and try to hear the sound of the clock through the other pipe. Adjust the position of the pipe so that we can hear the sound of the clock clearly. Now measure the angle of incidence and reflection. So this is the activity we can uh, clearly understand some topic. If we have any problem, then we do that with the help of experiment. We can clearly understand this type of topic. So 11.3 is the example. How can we easily understand the topic? For example, in this he says arrange the pipes on the table near a wall. This is the place the clock near the open end of the one of the pipe and try to hear the sound of the clock through the other end pipe. Adjust the position of the pipe so that you can hear the sound of the clock clearly. Now measure the angle of incidence and reflection. So he is saying this one, right? So lift the pipes on the right vertically on a small height and observe and observe what happens. So in this case, this is one pipe and this is another pipe, and they are positioned on between the wall. They are on the wall is between them. This is screen. He says screen. So the angle between this is angle of incidence, and on the other side, this is called angle of reflection. As we have, as I have already told you, what is the angle of incidence and what is the angle of reflection, right? So this is lying on table. So on one side of the pipe is our ear, and on the other side of the pipe is the clock is attached. What is going to do? Where I'm adjusting this pipe so that I can move this pipe this side or this side, where I can find the clear sound of the clock, clear sound of the clock. How can I find? I need to adjust this pipe on this side or in on this side to hear the sound of the clock. So these are the two pipes. One pipe is this, and this is the other pipe. So I will show you how he said in the statement. So in this state, take two identical plastic pipes of suitable length as shown in figure 11.10. I told you this is 11.10 figure, reflection of sound, 11.10 figure. So what he says what he says, arrange the pipes on a table near a wall. Look, so the first step is arrange the pipes on the table near a wall. Second step, place a clock near the place the clock near the okay. So place a clock near the place the clock near the open end of the one of the pipe and try to hear the sound of the clock through the other pipe. Third step is adjust the position of the pipe so that you can hear the sound of the clock clearly. Now measure the angle of the incidence and reflection. These are the four steps in order to hear the sound of the clock clearly. First, arrange the pipes on a table near a wall. Second, place a clock near the open end of the one of the pipe and try to hear the sound of the clock through the other pipe. Adjust the position of the pipe so that you can hear the sound. So you can hear the sound. Page number is 26, 26 and 27. I have already told you when you guys started it. So page number is on 26 and 27. We are doing. Take identical plastic pipes of suitable length shown figure 11.10. This, in order to hear the sound of the clock clearly, what we have to do. These are the two pipes. One pipe is on this side and one pipe is on the other side. So these are placed on the wall. So what are you going to do? If on one end the clock is placed and on the other end your ear is placed. So what you need to do, you need to adjust these two pipes where you can hear the clock sound clearly. When you hear where you find the where you hear the sound of clock clearly, then stop there and then you measure the angle of incidence in that case, an angle of reflection in that case. Where you hear the clock sound clearly, you will measure the angle of incidence and measure the angle of reflection. So this is the topic where how can you clearly understand clearly listen the sound of the clock clearly. This is the phenomena is called the reflection of sound. So now this is the end of the topic 11.3. Now we do the topic 11.4, which is sound speed of sound. So this is the table 11.1, which is on page number 27. You can hear this is on page number. You can see this is page number 27. This 11.4 topic is speed of sound is on page number 27. So if you look at the table here, this is the speed of sound in different medium. So suppose the speed of sound in gases. So gases, these are the gases. So speed of sound, air 0 degree. If there is a temperature is 0 degree, air temperature is 0 degree, then the speed of sound will be 333 meter per second. But if the air is 25 degree, the temperature of air is 25 degree, then air is 25 degrees, then speed of sound is 346 meter per second. If the air temperature is 100 degrees Celsius, then the speed of sound is 386 meter per second. Similarly, speed of sound in different medium is this is gases, this is liquid, and this is solids. So liquid at 25 degrees Celsius, the speed of sound is 1498, and the sea water it is 1531 meter per second. The speed of sound in seawater is 1531. So this is the liquid. The speed of sound is increasing. You can see the speed of sound in gases is 333. Is the temperature of air is 0 degrees Celsius. If the temperature of air is 25 degrees Celsius, then our speed of sound is 346 meter per second. If the temperature of air is 100 degrees Celsius, so our speed of sound is 386. Similarly, you can see this table, and the speed of sound in liquid at 25 degrees Celsius is, if it is distilled water, then the speed of sound is 1498 meter per second. It means the speed of sound is increased in the liquid. So speed of sound is more than speed of as compared to the in liquid as compared to the gases. So speed of sound in solid is more as compared to the liquids and gases. So speed of solid at 25 degrees, if there is a wood, then 2000 meter per second speed of sound. And similarly, the other speed of sound is more in the solid as compared to the liquid and gases. Now we read our topic 11.4. This topic, this table 11.1 is very important because they ask you in MCQs, in board examination, they will ask you MCQs from table 11.1. They can ask you. Sound waves can be transmitted by any medium containing particles that can vibrate. They cannot pass through. As when we discussed, when we start this chapter, sound chapter, I have already told you that the sound speed of sound requires some medium to travel. If there is no medium, then speed of sound cannot travel. For example, if you want to hear the sound of your friend, if you want to hear the sound of your friend, then what will happen? The medium should be air. If there is no air present, you cannot hear the sound of your friend. So, in order to be hear the friend of your sound of your friend, the medium must be present. In this case, the medium is air. But the speed sound cannot pass through vacuum. Vacuum means where there is no air. So for the transmission of the sound or from one place to another, so sound requires a medium, material medium, and the medium is air, right? So air must be there to hear the sound. Sound waves can be transmitted by a medium containing particles that can vibrate. They cannot pass through vacuum. So sound cannot pass through vacuum. If there is no air, it means that sound cannot pass through. However, the natural medium will attract the speed of the sound wave. In general, the speed of sound is liquid. In a liquid is 5 times that is gases. Look, in liquid, I told you speed of sound is greater than as compared to the gases. You know, the in gases the speed of sound is 333 meter per second, but in liquid it is 5 times more. If you take the 331 multiplied by 5, you will get its mean almost 5 times in liquid. So that's why he's saying speed of sound, the speed of sound in liquid is 5 times that in gases. Similarly, the speed of sound in solid is about 15 times that in gases. So if you take this one and this one, this means the speed of sound in air is affected. The speed of sound in solid is about 15 times that in gases. So it is more than 15 times as compared to gases. So In gases, speed of sound is very less, but in the solid, it is very high. The speed of, you can see 2000 or 6420, 4700. It is about 15 times as compared to gases. So speed of sound is more in solid than speed of sound is more in liquids as compared to gases. So it means the speed of sound in air is affected by changing some physical conditions such as temperature, pressure, and humidity. The speed of sound in air is 343 meter per second at 1 atmosphere of pressure, and room temperature is 21 degrees. If our room temperature is 21 degrees Celsius, then the speed of sound in air is 343 meter per second. The speed of varies with temperature and humidity. The more the temperature, the more it varies. You can see the speed of sound in air is zero. If the temperature is 0 degrees Celsius, that's my speed of sound is 331. But if the temperature increases from 0 degrees Celsius to 25 degrees Celsius, the speed of sound also varies. It also increases 346 meter per second. But if the temperature increase again, air temperature increase 25 degrees Celsius to 100 degrees Celsius, the speed of sound again increases 347. 386 again means speed of sound. More the temperature, more will be the speed of sound will be increased. So V is equal to F lambda. We have read this in our chapter number 10, last chapter when we discussed first chapter of the 10th class. So we discussed V is equal to F lambda. The speed of sound in solid and liquid is faster than in air, as I have already told you. The speed of sound in solid and liquid. This is solid and this is liquid. The speed of sound is more as compared to gases. Following relation can be used to find the speed of sound. So we can use this equation V is equal to F lambda, where F is the frequency and lambda is the wavelength. So V is the speed. So V equals to F lambda. So speed of we can find used to find the speed of sound with this formula V is equal to F lambda, where V is the speed, F is the frequency, and lambda is the wavelength of the sound wave. So, student, this is we studied about speed of sound in different mediums. We discussed about speed of sound in gases, speed of sound. Then we discussed speed of sound in liquids, and then we will discuss speed of sound in solid. So, speed of sound is very much in solid as compared to liquid and gases, and speed of sound in liquid is more as than speed of sound in gases. So, speed of sound is very less in gases but in solid. So we can find the speed of sound with this formula V is equal to F lambda, where V is the speed, F is the frequency, frequency is number of cycles per second, and lambda is the wavelength of the sound. Now by using this formula, we calculate the frequency of the sound wave speed based this numerical example 11.2. This example 11.2 is again on page number 27 of your 10th class book. So calculate the frequency of the sound wave of speed is 340 meters per second and the wavelength is 0.5 meter. So I will write the given data. Speed of wave is 340 V. Speed is denoted with the letter V and V is 340 meter per second. You know the unit of speed is meter per second. So speed of wave is V equals to 340 meter per second. Again, wavelength is given to me and wavelength is denoted with the lambda and lambda is given to me 0.5. So in this case, wavelength lambda is 0.5. I will use this formula V is equal to F lambda to calculate the frequency. Since I want to find out the frequency, to separate out frequency, so F is equal to V by lambda. So I will just put the values. V is equal to 340 and lambda is 0.5. If I solve this 340 divided by 0.5, we will get 680. And you know the unit of the frequency is hertz. So my frequency is 680 hertz. Now, this is the end of the topic 11.3. I repeat the whole topic. Now, what we did discuss today, we studied 11.3 and 11.4 topic today. Sound chapter we did, class 10, subject physics. Topic of today's lecture are 11.3 and 11.4, which are on page number 26, 27, and 28. This chapter, 11, chapter number 11, we are doing sounds, related to sound. Then we discuss 11.3 topic, which is reflection of sound, or reflection of sound is also called echo. So I read the definition for you. When we clap or shout near a reflecting surface, such as a tall building or a mountain, we hear the same sound again a little bit later. What causes this? This sound which we hear is called an echo, or is a result of reflection of sound from a surface. So I read the definition for you of the echo or reflection of sound. When sound is incident on the surface of a medium, it bounces back into the first medium. This phenomena is called echo or reflection of sound. To hear the echo very clearly, the time must be between at least 0.1 second, and the distance is total distance, two-way distance is 34 meters. But we are considering one-way distance, the distance will be 17 meters. Sometimes we hear multiple echoes. This is just because of multiple reflections or successive multiple reflections. So, students, in this topic, we talk about the definition of reflection of sound or echo and reflection of sound. Same thing in the board examination, they might ask you echo. Sometimes they ask you what define echo, or sometimes they don't say echo. They will say define reflection of sound. In both cases, you will write the same definition, right? So you will write the definition: when sound is incident on the surface of medium, it bounces back into the first medium. This phenomena is called echo or reflection of sound. The minimum time must be to hear the echo clearly must be 0.1 second, and distance of two-way distance is 34 meter. And if we talk about one-way distance, so one going, so that is 17 meter. So sometimes we hear multiple echo. This is just because of the multiple reflection. So we understand this topic or reflection of sound with the help of activity, and this activity is on page number 26 of your 10th class textbook. I did the activity. Take two identical plastic pipes of suitable length as shown in figure 11.2. We can make the pipes using chart paper. We can make the pipe with the help of the chart paper as well. Arrange the first step is arrange the pipes on the table near a wall. Second, place a clock near the one end of the pipe. You will place the clock, and on the other end of the pipe you will place your ear. Adjust the position of the pipes, position so that you can hear the sound of the clock clearly. Now measure the angle of incidence and reflection. Once you find that that you can hear the sound of the clock clearly, then you will find the angle of incidence and angle of reflection. This is the activity we did 11.3. He took the two pipes, one pipe, this is one pipe, and this is second pipe. So on the one end of the pipe, open end, you will place the clock, and on the other end, you will place the ears, right? And you will adjust these two pipes. When you hear the sound of the clock clearly, you will fix those pipes, and then you will measure the angle of incidence. This is called, on this side, this is called angle of incidence, and this is called angle of reflection. So we can understand the topic of reflection of sound with the help of this activity 11.3. Okay. So now then what we discussed in 11.4. This was the end of the topic 11.3. Then we discussed about 11.4, speed of sound. This is the another new topic, which is speed of sound. So speed of sound, there are the three mediums: gases, liquids, and solids. So I told you in in gases, speed of sound is if the temperature of the air is 0 degrees Celsius less than the speed of sound is 331. Then if the temperature increases, the speed of sound also depending upon temperature, humidity, these all these factors depending on. So if the temperature of the air has increased, as in case 0 degrees Celsius, it has increased 0 degrees Celsius to 25 degrees Celsius. So my speed of sound is also increased, which is 331 to 346 meter per second. Then if the temperature of the air is 100 degrees Celsius, then my speed of sound also has increased, which is 386 meters. Similarly, speed of sound at different temperatures in gases are given in this table, right? And then we discuss about speed of sound in liquids at 25 if the temperature is 25 degrees Celsius. Distilled water, if this is distilled water, that is 1498 meter per second. You should know the speed of unit of the speed of sound is meter per second. So distilled water, this is the liquid. So in case of liquid, speed of sound is 5 times greater than as compared to the gases. You should know. Look, 331 times 5 is 14, almost 1500. So it is more than 5 times in liquids. So speed of sound in liquid is 5 times as compared to the gases. Similarly, speed of sound in solid is 15 times as compared to the gases, right? So speed of sound for in solid at 25 degrees Celsius is 2000, aluminum like 6420, and you can see all these things. This is the case of solids, this is liquids, and this is gases. For speed of sound, you can find with the help of this formula, V is equal to F times lambda, where V is the speed, where V is the speed, where V is the speed, and F is the frequency, and lambda is the wavelength of sound. So we have discussed this formula V is equal to F lambda in our previous chapter. V is the speed, F is the frequency, and lambda is the wavelength. So with using this formula, I will solve the example 11.2. Calculate the frequency of a sound wave of speed 340 meters per second and wavelength 0.5. Wavelength 0.5 and wavelength 0.5. So calculate the frequency of sound wave of speed 340 meters per second and the wavelength is 0.5. First of all, I write the given data. The speed of wave is V, is denoted with V. V is equal to 340 meters per second, and wavelength is denoted with lambda, and lambda is 0.5. And lambda is 0.5 meters. Using the formula V is equal to F lambda, since I want to find out the frequency, the frequency will be V divided by lambda. So 340 divided by 0.5, if you solve with the help of calculator, you will find the result F is equal to 680. You know the unit of the frequency is hertz, so frequency unit is 680 hertz. So our result is frequency is 680 hertz. I hope students you understand all this topic which we discussed today. So your homework is memorize by heart the topics of today and write down this topic once. So you need to practice the example which we did today, and you need to write down the topics as well, and also solve your numerical on your neat copy. Uh, I hope you understand all this topic very clearly. If you have any question regarding this topic, please let me know and feel free to ask. More you ask, more you learn. So, thank you. I'm here to answer your questions. Please ask. Please ask questions. Ilsa, Fatima, Habibullah, Adnan, Harun, Yunus. If you have any question regarding this topic, please let me know. I'm here to answer your question. Please feel free to ask. More you ask, more you get. Please unmute your mic and ask question. Please do practice at home as much as you can of these two topics which we covered today, 11.3 and 11.4, and also memorize the table because this table 11.1 is very important according to the MCQ's point of view. MCQs comes in the board examination. Please feel free to ask a question. I'm here to help. I'm still here. Please ask questions. Unmute your mic and ask questions. Thank you.